Hello students, how are you? I hope you all are doing good. Okay, so today we are going to discuss something about chemistry paper discussion, which was done yesterday all over India. So I would like to see how many people can solve the paper. Let me see the questions first. Let's have a paper discussion, then we'll see what chapter it is from and whether it is easy question or not. We will check it. Okay. So now we are going to see the level of the paper first. And first one, this is from metallurgy chapter. So, and this is from periodic classification. Again, this is from metallurgy chapter. Yeah, this is from hydrogen. Okay, not hydrogen. This is from permanent hardness. Yeah, from hydrogen and its compounds. Yeah, this is from D block elements, coordination compounds, chemical bonding. This is a mixture of both ionic equilibrium and electrochemistry. Yeah, surface chemistry, Schottky defect, solid state, thermodynamics, solutions, mole concept. This is from either, yeah, halogen and its derivatives, biomolecules, again, aldehydes and ketones, same alcohol phenol ethers. This question is alcohol phenol ethers plus aldol condensation. Yeah, again, this one. This is elimination. Same elimination, chemical bonding, periodic table, chemical kinetics, and last one, aldehyde ketones. Okay. So now without wasting time, I hope you guys understand. I have, after seeing the paper, I can clearly sense that we all can solve at least uh, 12 questions for sure. 12 questions which are very easy. I will solve you here. There is nothing not to worry about that. Right. So before that, let me close my door. Okay. So you have not been disturbed, I feel so. Okay, just a minute. Correct. So I think many of you have joined the classes. So I'm seeing the YouTube stream is running good. Okay. So let me see any chat in our chat section. Anyone has having any doubts? Right. So there is no issues as far as my knowledge is concerned. Okay. So one only watching. Right. Okay. So without wasting time, let's start our discussion. I'll change my color. Right. So 12 questions we can easily solve, and majority of the questions from chemical bonding, and next one is we have also seen From metallurgy, we have seen 2 questions. Okay. Metallurgy, we have seen 2 questions. And very, very most important, like is organic chemistry, 12th part came very high. Organic chemistry, 12th class portion is very high. 12th class portion is very high. Okay. So 12th class portion is high. And 4th one is like periodic table. 1 question you got, very easy question. And chemical bonding, 2 questions came, which are very easy. 3 questions, periodic table, 3 questions came. Sorry, 2 questions came, which are very easy. And 5th one, mole concept question, easy, but bit lengthy calculations are required. And 6th one, I have seen that basically 6th one I have observed, what we can say, electrochemistry plus tricky question, electrochemistry plus ionic equilibrium question, plus what do you say, the thermodynamic question, all these are bit trickier one, but we can solve this question. So overall I feel like this question you can get 45 marks easily, like easy. And if you push yourself somewhat higher, you may get 55 for sure. So 45, 40 plus questions you can do it. 55 you can do it if you have an idea about that one. Without wasting time, we'll dive into the concept. So we have asking about the question like, which of the following ore contains copper metal? Which of the following ore contains copper metal? So fool's gold, malachite, dolomite. Dolomite is actually Al2O3, 6H2O. This is ore of alumina. Okay? And galena is PBS. Okay. Lead sulfide is galena and malachite is copper sulfate. Copper sulfate. Okay. So that is why the presence of, sorry, copper hydroxide will be present. That is, copper will be present in the malachite. So fool's gold and dolomite and all. And I am going to give you the homework today. Go and check what is German silver. Okay. And next gunmetal. Gunmetal. German silver, gunmetal, and brass, bronze. Brass and bronze. Okay, so brass, and 4th one is bronze. Okay, so these 4 are very, very most important for your examination. So go and check these elements and what is corundum. Okay, and Epsom salt. So whatever that are running in my mind, I'm writing gypsum. Okay, plaster of Paris. Okay, these all are some of the important questions. Mohr salt. Okay, so in your examination, the questions will be asked from these, compounds, what type of elements are present and all. Okay, so another one is calamine, very, very most important, calamine, ZnCO3. Okay, and hematite, ores of iron. Simply, I can say that ores of iron, they will ask you. Okay, so these are the some of the important topics about, for your examination is really important. So without wasting time, we will move to the next question. Yes. So which of the following diagram is correctly, matched? Okay. Which of the following diagrams is correctly related to the electron affinity of the halogens? And first of all, to do this question, we need to know the trends, the periodic trends in the periodic table. So what are the periodic trends? We have no electronegativity, electron affinity, ionization enthalpy, and especially in your examination, we all need to remember for the exceptional cases. So exceptional cases are really important. I'll write the exception cases here, which are most predominant in your examination. Among fluorine and chlorine, fluorine will have more electronegativity. So in the halogens, the electron affinity will become chlorine will have more than fluorine, then bromine, and then iodine will come for the halogen family. This is the order of the electron affinity. Why the exception case here? Usually from left to right. From left to right, if you see, electron affinity will become what? What it should be? It should be increases. And from top to bottom, it should be decreases. Okay, now so top to bottom it should be decreases. So, but why in this particular case fluorine is having less electron affinity compared to chlorine? Because of small size, and repulsions. Because of small size and the repulsions will made the fluorine having lesser electron affinity compared to chlorine. छोटे साइज होने की वजह से वहां पर इलेक्ट्रॉन्स आकर, ठीक है, तो रिपल्शंस करके एनर्जी लेस रिलीज करना होगा. सो बेस्ड अपॉन दैट वन, व्हिच इज द करेक्ट आंसर, between fluorine and chlorine there will be an increase. Yes, here increase and here increase, so you can directly eliminate these two options. Fluorine and chlorine, this is increase, and then increase here, no, it will be decreases. So option C is the correct answer. So this is the perfect trend. Another exceptions for oxygen family, usually examination will be asked oxygen, sulfur, selenium and tellurium. This is the general trend used to follow. This is the general trend, but this is wrong because of the small size of oxygen and sulfur. Now the original order will become sulfur, selenium, tellurium and oxygen. This is the order of electron affinity. Every year in JEE Mains and NEET, these kind of questions has been asking. Okay, now. So next one, you people need to remember potassium, rubidium and cesium are having nearly same electron affinity values, and argon and krypton. Okay, argon and krypton is also having nearly same values. Argon and krypton is also having what? Nearly same electron affinity values. Next, the slag obtained during the extraction of copper from the copper pyrites is composed mainly because of, see, the slag I told you, like slag and flux plus gangue is simply nothing but what? Slag. So flux plus gangue is called as slag. So slag is simply nothing but iron silicon oxide. So because of the presence of silicon, okay, you are going to get what? Formation of a slag will going to takes place over there. Okay, so I request everyone to check the metallurgy chapter more precisely. The reason, because in your JEE Mains examination, definitely one question is going to ask you for sure. Okay, so in that for that reason, you all need to check the questions very clearly, right? Yeah, so irons, silicon trioxide will be the slag. Okay, next one, the permanent hardness is due to the presence of, yes, so we know that we need to know, this is from the hydrogen chapter, very most important. From the hydrogen chapter, this question is from. So this question in this chapter, you people need to focus on the structure of H2O2. Okay, and we can also see structure of H2O2. Sorry, this is from S block elements. Okay, this chapter is from S block elements. Remember, from hydrogen chapter, structure of H2O2, volume strength, and the comparison between D and T, isotope comparison with the hydrogen. And from the S block elements, especially S block elements in alkaline metals, we have seen the capacity, or which we can say that the formation of a hardness inside the water, or we can say there are two types of hardness: temporary hardness and permanent hardness. Temporary hardness are basically because of calcium and magnesium salts, and they can easily gone by just boiling it. Okay, normally if you boil, the hardness will go. But for the permanent hardness, you require some other things to remove the hardness. We need to add washing soda or some other things. So remember, permanent hardness is simply because of chlorides and sulfides of calcium and magnesium. Highly powerful. Okay, so this question is also important for your JEE Mains examination. MnO4 minus is purple colored due to, what is the reason MnO4 minus is purple colored? Many a times in our S block and P block, whenever we are reading the inorganic chapter, what we have observed, like this is from D block elements. Okay, this is from where? D block elements. So whenever we are studying any particular elements, what we have observed, the color is due to DD electron transition. So DD electron transition is responsible whenever the electron jumps from lower energy state to higher energy state, it feels unstable. So whenever it will come back, it will release some energy. That energy is simply nothing but hc by lambda, will have some wavelength, will have some frequency. Because of the excitation from lower state to higher state and becoming unstable, it will reach the ground state by releasing some energy, which leads to a giving a complementary color. We study with the complementary color cycle. But especially in the case of MnO4 minus, so MnO4 minus, the color property is due to the charge transfer phenomena. So the oxygen will try to send its charge by a back bonding. By back bonding, it will send the charge to the manganese. Because of the charge transfer, the color of MnO4 minus will be possible. Simultaneously, Cr2O7 is also Cr2O7 2 minus is also having color. Okay, so this is pink in color. So why these colors are coming? Because of the charge transfer phenomena. Another one is ligand to metal transfer. Ligand to metal transfer is also we can call it as, okay, here ligand to metal transfer or charge transfer phenomena is the reason for the color in this MnO4 and K2Cr2O7 compounds. Very, very most important. Yes, next one is from coordination compounds chapter, from the coordination compounds chapter. So this is another easy question. We can say that coordination compounds chapter, NiCO4. NiCO4 is nickel tetracarbonyl and its oxidation state is always considered as 0. So NiCO4, the oxidation state is 0. So we have to check the ground state of nickel, that is Ar 18 4s2 3d8. Ar 4s2 3d8 is the ground state configuration. But as nickel is in 0 oxidation state, we simply whatever the state, that will become like this. So now if you are observe this one, if I am drawing the ground state electronic configuration, so let me draw for the d orbitals. Right, so this is the d orbitals, 1 2 3 4 5 6 7 8, and 2 unpaired electrons are present. Okay, and s orbital is having 2 electrons. Okay, so but what will going to happen whenever the ligands, whenever the metal carbonyls like these carbonyl compounds are coming, due to the back bonding with the nickel, due to the synergic bonding, we will have this electron will jump. So because of this, we are going to have sp3 hybridization. Okay, because of this, sp3 hybridization will be takes place. That is 3p orbital will involve in the bonding. So that's why we are having sp3 hybridization. Okay, 31 will become what? Okay. Oh, wrong statement they are asking. They are asking about the wrong statement. So wrong statement means we can clearly say that it is actually tetrahedral one, but they have here they have mentioned square planar geometry. Unpaired electron is 0. This is wrong actually. Okay, so unpaired electron will become 0 whenever there is a bond formation will takes place, then it will be correct. Yeah, diamagnetic complex, because after bond formation it is sp3 hybridization. Yes, but it is a tetrahedral complex, it's not a square planar complex. Square planar complex is nickel tetracyanide ion. Okay, this is very, very most important. So this is square planar complex. This is basically from our NCERT only, right? Next, ICl2 plus and ICl2 minus and ICl4 minus. Sum of the bond pair, lone pair, and each pair on each iodine atom are respectively. So among this one, we have to find the bond pair, lone pair. So we know that iodine Cl2 plus. So iodine is taken as central atom. How to decide a central atom? Which is having less electronegativity will always preferred as a more in size, and less electronegativity will always preferred as a what? Central atom. Now, if you find the hybridization number, so that we'll get to know how the structure will become. So now that is half into 7 plus single bonds, how many? 2 plus 1 is, that is simply nothing but -1. So that is 7 plus 2, 9 minus 1, 8. sp3 hybridization. sp3 means tetrahedral. Tetrahedral 1, 2, 3, 4, 5, 6, and 7. 2 chlorine atoms are there. 1 and 2. Plus 1 का मतलब क्या होगा? We have to remove one electron. We have to remove one electron. Then total how many electrons are there? 1 and 2. So that means we are having 2 lone pairs plus 2 bond pairs. 2 lone pairs and 2 bond pairs. So 2 lone pairs and 2 bond pairs are there in the case 1. So the sum of bond pair and lone pair on each iodine is, okay. So 2 lone pair and 2 bond pair, that is 4. So you can directly eliminate these two. Okay, you can directly eliminate these two. And next one we are seeing, yeah. So last one, if you check, then our answer will be clear. So that is ICl4 minus. ICl4 minus means iodine 1, 2, 3, 4, 5, 6, 7. Minus is there, so that's why I am taking another one. Total 4, right? 1, 2, 3, and a fluor. 4 means these two are 2 lone pairs plus 4 bond pairs, that is 6. So the answer will become 4, 5, and 6. So D is the correct answer. Okay. I hope you guys understand this one. Correct. Right. Next one. Yeah, this question is a bit important. I have solved on my own. Okay, this question is a mixture of both electrochemistry and what is that one? Ionic equilibrium. So for the KSP, if I am writing for BaSO4, if I am writing KSP, how you are going to write KSP for BaSO4? BaSO4 will trying to dissociate in the form of, what is KSP? KSP is simply nothing but solubility product for the sparingly soluble salt. That is Ba plus 2 plus SO4 2 minus. So if you are taking this as initially X and 0, 0, and what will going to happen here? This will become X and X. So if I am writing KSP, okay, so the concentration of Ba products concentration into, okay, divided by the reactants concentration. Correct. So based upon that one, we have to write, and that is we have to find here. Okay. So simply we can, let's suppose if the dissolution is remains same. Okay, then you can write KSP as X square. Okay, KSP as X square if you are, if both are same, if they are dissolving same. Usually it will be same when there is no common ion is present, but directly KSP you can write as X square. For AB you will write it as KSP will become X square. Okay, how you are writing KSP? KSP is equal to X to the power of X, Y to the power of Y, and S to the power of X plus Y. And here X is 1 and Y is 1. 1 power 1, 1 power 1, and S is simply nothing but, yeah, S if you take 1 plus 1. So that is S square. Now KSP will become what? S square. Now you want to know S here. S is simply nothing but what? Solubility, or we can also take it as concentration. Okay, so now these all are the basics terminologies we have to know. And now let me erase these things so that it will be very clear. So limiting equivalent conductance, okay, so we need to find for the specific conductance of the saturated BaSO4 solution is Y. He himself already given specific conductance. Specific conductance means kappa is given as Y. Now equivalent conductance for BaSO4, how you are going to calculate? By adding equivalent conductance of BaCl2, okay, that is BaCl2 plus equivalent conductance of H2SO4 minus 2 times of equivalent conductance of HCl. So which is leading to be X plus, which is X1 plus X2 minus 2X3. Okay, and we know limiting molar conductivity is how you are going to write it as, okay, that we are going to write it as what? K into 1000 divided by, okay, what? C. Correct. So now C is simply nothing but what? K into 1000 by molar limiting conductivity, this one. So now C is equal to K into 1000 divided by, what is lambda equivalent for BaSO4? That will become what? X1 plus X2 minus 2X3. Okay, X1 plus X2 minus 2X3. Okay, let me erase this one so that we can write here. I could have added the slide, but I couldn't make it. Now, if you can see here, then that is C will become K into 1000 divided by x1 plus x2 minus 2x3. Correct? Right. Now, KSP we have seen. KSP is what? Simply C square. So that is K is equal to what? Y. So that is KSP will become Y into 1000 whole square divided by x1 plus x2 minus 2x3 whole square. So now KSP will become what? KSP will become y square into 10 to the power of 6 divided by x1 plus x2 plus, sorry, x2 minus 2x3 whole square. So which is the correct answer? The answer is, yeah, B is the correct answer. Very easy question, right? But this question is a mixture of what? Mixture of ionic equilibrium plus electrochemistry. Like these only you are going to get. This is the one of the most important question and my favorite question in this question paper. Okay, I like the question actually. Right. Next one. When a direct current source is passed through the colloidal solution of iron Fe3, okay, iron oxide, that is ferric hydroxide, using inert electrode. So this is a direct question actually. So whenever there is a, remember FeO thrice, okay na? So this is called as ferric hydroxide. So ferric hydroxide, colloidal iron hydroxide is saying. So that is why which is a positive soul. So positive soul will always collected at where? Negative electrode. Okay, so it will precipitate. Its precipitate will be collected near negative electrode. Okay, so Fe plus 3 is a positive soul. So its precipitate will be always collected at what? Negative electrode because of the positive negative charge. Okay now? Yes. So next one, if all the atoms touching one phase plane are removed in a solid NaCl, then the formula of the compound left in the, okay. So if let's suppose FCC, if I am talking about, so which chapter it is? Very clear. This is solid state. This is which chapter? Solid state. So solid state, if you am seeing here, okay. So right. So in FCC, how the atoms will be there? Atoms will be at the 4 corners, that is 8 corners. Okay, so the contribution of corner atom, usually let's suppose sodium is present. And next, okay, so let's suppose these all are chlorine atoms, okay, or iodine atoms. So let's suppose if all the phase centers, how many phase centers are there? 6. 8 corners, and each corner contribution is 1 by 8. So the total contribution will become 1. And total 6 phases, and each phase will have 1 by 2 contribution, total 3. So the total number of atoms in FCC will become 4. And if we are taking the NaCl, which is in simple ratio, what they are telling here, then if the all atoms touching one phase plane are removed. So if I am trying to remove the phase plane, okay, atoms, what is going to happen? Their contribution will become 1. So now the formula will not change, will remain NaCl. And what is the type of defect? If you are removing certain thing, okay, if you are removing certain thing from the crystal, what will going to happen? There will be a decrease in density, which is simply nothing but Schottky defect. Okay. So Schottky defect is the correct answer, and NaCl जैसा है वैसा रहने वाला है. ठीक है? So next one is very most important question from the thermodynamics point of view. So these involves in the calculations actually. So it requires some pre-knowledge. So that's why I'm trying to answer here. Okay. So now, first of all, whenever these kind of questions has been given, you have to convert them into what we call, we have to convert them into kelvins, okay? Or else you just check the question how to do this one. Generally, 10 mole of an ideal gas is heated at a constant pressure 1 atmosphere from 27 degrees to 37 degrees. If CV CV per mole is given in this particular equation, then find the delta H. Change in enthalpy they are asking, or internal energy we can also call it. So how to calculate this one? This one is very, very most important. How to calculate? First of all, we need to find the work done. Work done, how is that one? Minus P delta Y. Okay, work done by the gas itself. Okay, that is minus P delta V, or else minus NR delta T. Okay, NR delta T. Why? From the ideal gas equation, EV is equal to nRT. Correct. So now in this case, as pressure is given, but the change in volume is not given, so we can take the second equation. That's why W is equal to 2 minus number of moles is 10 into R. R value, how much we have to take? The answer is in joules. So that's why we have to take 8.314. R value can be taken as 8.314. The shortcut is 25 by 3. You can write it also 25 by 3. D2 is simply nothing but T2 minus T1. So W is equal to minus 10 into 25 by 3. I'm just simply writing this one in this form of, and T2 minus T1 is simply nothing but 100. That is 127 minus 27, which will, you are going to get 100 degrees Celsius. Okay. So now if you are taking this one, W is equal to 2 minus of 25,000 divided by 3. This is also coming around something called as 83 something only. It will going to come around 8 3s are 24. So 24 वहां पर 10 है तो 9s are 0.383. Okay, so that is simply nothing but W is equal to minus 8.3 into, okay, like this if you are writing. Okay, now we already know that internal energy, how we are going to calculate delta U or delta H is equal to NCV delta T. So you have to do what here? CV we know, that is DH is equal to 2, and delta T with respect to T we are doing. So that is we have to integrate N into C20 plus 10 to the power of square T into delta T, and we have to do what? Integration on both sides. So whenever we are doing the integration, so integration of DH, you are going to get as the answer for that one is will become H. So that will become what? N is 10 into 20 minus 2. Okay, integration का क्या है? Integral of T is simply nothing but T square by 2. अरे so sorry. Integral x का value कितना होगा? X square by 2. So that is H is equal to 10 into 20 minus 2 into T 10 x square by 2, T square by 2. This is cancel, and the lower limit will be, we have to convert them into kelvins because here you see Kelvin is there. So that is from 300 to 400. Lower limit is 100 and upper limit is 400. So upon doing the calculation, you are going to get 3181 kilo, 31814 joules. That is 31,084 joules. I hope you guys understand. Very difficult question or easy question, I will not say, because it's pretty important. I don't want to discuss these things. I just want to jump to the last question. I will come back and from there, so that we can do some couple of good questions regarding related to our 12th syllabus. Okay. Correct. So just a minute. I don't know why, what happened. Just a minute, guys. Very good question and easy question. How many compounds will give chloroform with Cl2 in the presence of NaOH? So Cl2 in the presence of NaOH, after looking to that one, yes, it is a haloform reaction. Haloform reaction. So what are the primary conditions we all need to remember from the haloform reactions? Alloform reactions are usually treated with the methyl ketones. Okay. And what are the products you are going to get? Salts of carboxylic acid. What are the products you are going to get? Salts of carboxylic acid. Salts of carboxylic acids plus haloform. Salts of carboxylic acid plus haloform. Okay, na? So here methyl ketones are sometimes they also consider alpha hydroxy compounds, alpha hydroxy alcohols. They also consider sometimes alpha hydroxy alcohols. So let's suppose if you are having NaOH in the presence of I2, okay. So what you are going to get is like NaOI, or let's suppose X if I am taking. So if I am taking X, NaOH in the presence of any halogen gas, you are going to get NaOX. Okay, so from these you are going to get a nascent oxygen, which is help in the oxidation. Okay, which is help in the oxidation. So pretty important that whatever the compound, it should consist of what? A methyl ketone. So let's suppose if you are having CH3 C double bond OH, okay, this can give because it is consists of methyl ketone, and you can also see CH3 C double bond O CH3. This combination will also give iodoform haloform test. Or else sometimes CH3 CH2OH is there. If you are treating with NaOH in the presence of Br2 or Cl2, what you are going to get is first formation will become oxidation of alcohols will leads to what? Oxidation of alcohols will lead to aldehydes. CHO. Again, same story. You are going to have CH3, C double bond O, H. Okay. So here you are having the methyl ketone. So this can also give the positive haloform test. So now this will give the positive haloform test. This will give the positive haloform test. This is also will give the positive haloform test. Methyl will not give, and these all other compounds will not give the positive haloform. Okay, so only 3 compounds are giving. This is also will not going to give the haloform test, right? Yeah, another favorite and very important and easy question in the examination. Okay, right. What is that? So following figure shows a graph in log K where 10 base as versus 1 by T, where K is the rate constant and T is temperature. There is a straight line BC, okay, has a slope tan theta is equal to -1 by 2.3 and has an intercept is 5 axis. Very simple. We got to know from the rate constant equation K is equal to A into e to the power of minus EA by RT. Okay, na? So now if you are taking logarithms on both sides, log 10K is equal to log A into log base to the power 10 E into minus EA by power RT. This is in power of E. And we know log to the base 10 E is simply nothing but what? 2.303. Okay. So because we know that log 2.303 times of log 10. Okay. This is simply nothing but ln x, and this is 2.303 times of log x. So that is why we can find it can finally convert into log to the base 10 K is equal to log A minus EA by 2.303 R into 1 by T. 2.303 into R 1 by 3. Okay, so now if I am plotting this one graph, with that you can clearly say that this will become C. So log A will become intercept, that is 5, they are already given, and minus EA by 2.303 R will become what? Tan theta, which is slope, which has given as minus 2.303. So this one cancel, and minus cancel. That is EA by R is equal to 1, which is simply nothing but EA is equal to what? R. That is activation energy is equal to R, and R is equal to what? 2. calorie per mole Kelvin. Calorie per mole Kelvin. If they have given mentioned R value or anything here, that will be good. If they have not mentioned, then you can take R value as 2, or R value you can also take 8.314 kilojoule per mole Kelvin. Okay, so I don't know, like at the end pen tab is not working, so please try to manage this one. Okay, so the answer R can be 2. R can become 2 if it is a, the R value is calories per mole Kelvin. Okay. Yeah. So how many elements are more electropositive than chlorine? Okay, electropositive nature than chlorine. So we'll just write one thing. Electropositive nature, from top to bottom we will see, and from left to right also we will see. Okay. So top to bottom, electropositive nature will be increases. Okay. And what about from left to right? Left to right, it will be decreases. Okay. Left to right, it will be decreases. Right. So left to right, it will be decreases. Now we will take some of the examples. Beryllium will be here. Okay. Fluorine will be here. Fluorine will be here, and oxygen will be here. Sulfur. Then here nitrogen will be there, and here phosphorus. Hydrogen will be here, and the sodium will be there. Chlorine will be here. I will change the color so that it will be easy for you. Right? And what about gold will be somewhere around here. Okay. Okay, fourth period it will be sulfur, phosphorus, hydrogen, sodium. Yeah. So now we know that this is most electronegative element, and this is also most electronegative. This is also most electronegative, because fluorine is most electronegative than oxygen and nitrogen. Then there is having chlorine. So it is pretty clear that these are not electropositive, these are more electronegative. And chlorine and sulfur is less electronegative compared to chlorine. So that means it is electropositive. Phosphorus is electropositive, sulfur is electropositive, sodium is electropositive, barium is electropositive, hydrogen and silver also. So total how many compounds are electropositive here? Beryllium, hydrogen, 3, 4, 5, 6. Is there anything is missing here? 1, 2, 1, 2, 3, 4, 5, 6. Okay, phosphorus I have taken, na? Sulfur there, phosphorus there, hydrogen, copper I have seen. Oxygen is more electronegative, hydrogen is there, beryllium is there, sodium is there, 3, 6, total 6 only answer, correct. 6 elements is having more electropositive than chlorine. Okay, very easy question, right? Next one, find the total number of compounds which are colored species. This is a practical organic chemistry question. Cl2 practical chemistry question, not organic. Cl2 is yellow greenish color, or we can also say greenish yellow color. Greenish yellow color. Okay, greenish yellow color. So let me change the color. Okay, greenish yellow color. And next one, NO2 is brown color. Among the nitrogen oxides, NO2 is the brown color, and N2O3 is blue solid. N2O3 is blue crystalline solid. Only these two nitrogen oxides shows color. And next one, ammonia. Ammonia is colorless. Ammonia is colorless. And next one, CDS. CDS is having CD plus 2 and S2 minus, because of plus 2. Cadmium will exhibit color. Okay, so due to DD transition, and the color is yellow, and the color is yellow due to DD transition, cadmium will show. And N2O4 is colorless. I told you only two nitrogen oxides are color, that is N2O3 and NO2, which is a brown. Next one is Cu2 FeCN6. So that means if you dissociate 2Cu plus FeCN6, FeCN6 2 minus. So which you are going to get what? Fe that is what you are going to get here. Minus 6 is equal to minus 2. Then Fe is equal to plus 6 minus 2. Fe will become plus 4. So iron which is in plus 4 state is highly impossible, but still copper which is in plus color is a blue color one. Okay, copper red is sorry. Copper which is in plus 2, that is blue. Okay, and copper which plus 1 is red color, and due to iron is present, chocolate red we will call it as chocolate red color. Okay, so total how many species? This is color. Total 4 species are colored and rest of them are non-colored. Okay, I hope you all are clear. Next one, how many of the following are planar? Okay, planar structures they are asking. XeF2, yeah, this is linear structure. All will exist in one plane. Next, ClF3 we have seen. ClF3 is a T shape. This is XeF2 will be like this. Okay, 180 degrees, and this is present in one plane. So this is planar one only. And ClF3 if you are taking, it will get sp3d hybridization. And if I'm trying to draw the plot here, chlorine, and fluorine. So these are 2 fluorines are outside the plane, and outside of the above the plane and below the plane, and this is not a planar one. Next, H2O, obviously this is bent V shape. H2O is a bent V shape structure. And XeF5 minus is simply nothing but 8 plus 5 plus 1, 6, that is 14, 7, sp3 d3, which is pentagonal planar, which is what? Pentagonal, which is pentagonal planar. Xe 1, 2, 3, 4, 5, F, 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 and F. Okay, so this is minus, this is called as pentagonal planar. Okay, so this is correct. Next one, I3 minus, if you see, again I3 minus is sp3d hybridization, and it will be look like this. Iodine will be present at the center, another hydrogen will be above the plane, below the plane, but they are existing in one plane. Actually they all are existing in one plane, which is linear in structure. Okay, and here what you are going to have a lone pairs. This is linear in structure. Next one, BeCl3, yes, trigonal planar. XeF4 square planar. SF4 seesaw safe. PCl5 trigonal bipyramidal. SF6 octahedral. This is pentagonal bipyramidal. These are not going to be present. And how many compounds are there? 1, 2, 3, 4, 5 compounds have been given are planar structures. Okay. Yeah. So last 10 minutes, 5 minutes, last 5 minutes. And concentration of H2SO4 in and when you are eating. So concentration of H2SO4, if you are heating, what will going to happen? And this is from hydrocarbons chapter. So we are going to do what? Beta elimination. We are going to do what? Beta elimination. So first here you are going to get H plus from this one. So that H plus. So let me carbocation formation takes place. Oxygen is having lone pairs here. Now H plus will attack here as this is electrophile. Now what will going to happen here? Here you will have OH2 positive charge. Whatever the shared pair of electron, this will be taken by H2O. And now what will going to happen here? What will going to happen here? Right. So now you are going to get a positive charge here. Now positive charge, and this is what? 1, 2, 3 tertiary carbocation. So tertiary carbocation formation is taking place, but we have to see what? Ring expansion. So ring expansion will be what? Break this bond here, and take this one here. Okay, so that means you will have a 6-membered ring. Okay, like this. You are having a positive charge, and from here, sorry guys, sorry. And if I am breaking this one, and if I am attaching this here, you are going to form a compound like this. positive charge on this one and one positive charge on this one. You will have one hydrogen here, another one here. And after removing the hydrogen from here, you are going to get a compound like this here and here. So very another most important thing, how to find the final product as a major product means check the alpha hydrogens. Check the alpha hydrogens. If you checking the alpha hydrogens, then you can easily find the major product. So from these particular case, if you are seeing here, what is going to happen here is like you are having CH3, 6 alpha hydrogens plus 1, 2, 7, 8, 9, 10. So 10 alpha hydrogens are possible here. And here you are having only 2, 3 alpha hydrogens. And here we are having how much? Here 1, no, here to nothing, 0. And here 2 only alpha hydrogens. And here you are having what? CH3, CH3, CH2, CH2. 10 alpha hydrogens are there. But due to the formation of carbocation stability, this is the most favorable compound. Because of formation of carbocation, ring expansion will take place. Next one, yes. So this is elimination reaction. Alcoholic KOH is do elimination. E2 elimination will always chlorine and D, which are in other plane, will be removed as CLD here. That is HCl kind of DCl. Then you are having a compound C. Okay. This is another easy question. And this question I have tried, but I couldn't make it. But I will let you know in the next class. Another important this question is actually a mixture of Markovnikov rule plus Aldol condensation. This question is a mixture of Markovnikov rule and Aldol condensation. So first one you are having HC C triple bond CH. Then if you are having H2O H plus and OH minus, what will going to happen here is like CH H OH OH H, this will going to happen. So upon this one, what will going to happen here is again, okay, triple bond is double bond is there. Again, this double bond will break and this will going to from H, C, OH, 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 OH and H. So from here, you have to remove the water and at the end you are going to get water. C double bond OH, C double bond OH, diketone kind of compound. You are going to call it as not diketone. This is called as glycol. This is called as glycol, CHO, CHO. And now with this, what you are doing with this? With this, you are doing aldol condensation. So aldol condensation you are doing. So from here, OH will be there. That OH and H will go on, and B will be the most stable product. B will be the most stable product. That is aldol condensation. Yes, in condensation, one alkene will form. Among all the options, B is only the more suitable one. That is our answer. When you want to answer more quickly, dilute NaOH and heating you are doing, right? So aldol reaction plus heating means condensation. Obviously, you are going to get a beta hydroxyaldehyde. Okay, so that is why I am telling you that enol formation you have to check. Enol formation is only possible at B case. Okay, and this one is reduction. First one is reduction. So upon reduction, what will going to happen? This will go and the product will be like this. Okay, and the product will be like this, right? And then you are having HCl, that is addition reaction. H plus will attack at more number of hydrogens, Cl will attack at less number of hydrogens. So that is here, this will break, here H will attack and here Cl. So the only option is B. Okay, B is the answer. I'm moving a bit faster, the reason because as we are having a time constraint, right? So very easy question. DNA as present in which case? That is cytosine and thymine. Okay, cytosine are uracil or thymine and adenine. Okay, so that is why this you people CTU. Just remember CTU. Okay, so this is the possible cases. Cytosine. Okay, NBS reaction. If you see, this is an allylic addition actually CH3, which if you are adding NBS in presence of CCl4. What is going to happen? CH2, CH bond, CH2Cl, and you are having sodium in presence of dry ether, that is Wurtz reaction. Next one is what? Wurtz reaction. So Wurtz reaction means what? Again Cl, CH2, CH double bond CH2. So here Cl will be gone and your product will become total 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. Okay, and double bond at the ends. So the only product is this one, which is option C is the correct. First one is N-bromosuccinamide, which is undergo allylic addition, allylic bromine addition. Okay, allylic bromine addition, which is undergo free radical mechanism. Then you are having Wurtz reaction. Okay, so final product will become C here. So these are some questions, 3 questions left. You can do it. Okay, I hope everyone understand this one. We will see you in the next class. Thank you guys. Thank you for joining the class. Okay, I know I have went bit faster. The reason because this is a question paper discussion session. I have covered almost all questions. There are some mistakes might be there. So try to do the question paper again and you will get the solutions in the WhatsApp group. Okay. Thank you guys. Have a happy Sunday.